This is number 8 on the back of page 3 in your packet. You've got 6k over k squared minus 9 plus k over k plus 3. The strategy is still the same. Factor, you're going to just rewrite. It's a true statement from one statement to the next. All you're doing is rewriting something that's true, but you start by factoring the denominator only. 6k in the numerator right here, I'm going to ignore it, over k squared minus 9. That is the difference of two perfect squares, which factors to k plus 3 times k minus 3. Okay. Then plus k over k plus 3 is already factored. Remember that you cannot, it might be tempting to want to say k over k cancels. Can't, because k plus 3 in the denominator is being added or subtracted. When you don't know what k is, you don't know if it cancels or not. You can't tell if it's a 1 because k plus 3 is what's in the denominator. So don't do that. All you're going to do now is analyze. I've got a k plus 3 on the left-hand side. I've got a k plus 3 on the right-hand side. That's fine. But then on the left-hand side, I have a k minus 3, and there's nothing to match it on the right. All you do, and it's the same exact thing that you've been doing, multiply by a form of 1. That form of 1, though, in this case, is going to be k minus 3 over k minus 3. Okay? And remember, numerators, denominators, when there are trinomials, binomials, put parentheses around it. Okay, so now I'm looking at it again. I've got matching denominators, which means I can combine all of this over k plus 3 times k minus 3. And I just have to do the math at the top. 6k, there's no math you have to do. Plus, I've got to multiply k times the quantity k minus 3. That's a distribution problem. And so that's going to be plus k squared minus 3k. So let's do the math in the top. You're going to combine like terms. K squared doesn't have a like term. And then I've got a 6k and a minus 3k, so that would be plus 3k over k plus 3 times k minus 3. Once you've done the work in the numerator, you have to look at it and say, okay, all the math is done, it's simplified, but are there factors? You're looking to see if something will cancel. And I noticed that if I look at k squared plus 3k, yeah, I can actually take a k out of both of those terms, and that would give me k plus 3. So I've just rewritten the numerator, and the denominator's just still sitting there ready. Now, you remember what I said, you're looking for forms of 1. If you want to cancel any kind of polynomial, binomial, which means two terms, it's all or nothing. You can never cancel out of an addition or subtraction problem, but you can cancel all of an addition or subtraction problem. And hopefully you're noticing here, k plus 3 over k plus 3, that's going to equal 1, which means that can cancel. And what you end up with is k over k minus 3. Do not be tempted to cancel those k's. You can never, never, never cancel out of an addition or subtraction problem. That is simplified.